So a three-phase AC source with a inductance in series. So there are three inductances that is there in series with the three-phase source. Now in most of the application, a synchronous machine is connected to another three-phase source which we call it as a grid. So this is my synchronous machine. And this is my grid, which is again a three-phase source. But the difference between a grid and a synchronous machine is that a grid do not have an inductance, or the inductance of the grid is taken to be 0. So before we start synchronous machine, we would like to understand how two AC sources when connected together they work. Now this is a three-phase AC source and this is balanced. Since it is balanced, it can be thought as if there are three single-phase sources and the response due to three phases will be nothing but 3 times the response due to one source. So this problem can be reduced to a single-phase AC source connected to another single-phase AC source. So this is my synchronous machine. This is my grid. In this course, we will come across many instances when we will find such a circuit. It is obvious that you have studied this, but it will be nice to have a revision of this. So, in first few lecture, we will study a circuit where power will flow from one AC source to another AC source with an inductance in between. We will also study what will happen if we replace this inductance with a resistance or a combination of a resistance and an inductance. So let's first take one example. This is my synchronous machine. So let's write this as V1. Since it's an AC source, it will have a magnitude and a phase angle. So let's say that V1 at an angle theta 1. This is my grid. This is another AC source. So let's take this as another voltage source as V2 at an angle theta 2. And let's say that this is an inductance having an impedance X with a phase angle 90 degree. And let's say that the current that is flowing here is I at an angle theta. So if we apply KVL in this circuit, what we can write? We can write V1 at an angle of theta 1 is equal to V2 at an angle theta 2 plus I at an angle theta into X at an angle 90. Now if we solve this equation, we can find the variables. Now this problem is very fundamental and we will take number of examples to understand what happens. Let's go back one step and take another simple example with a DC circuit. Let's take this as a DC circuit having two voltage sources. This is V1, this is V2, this is R, and this is I. Now how we will write KVL? We will write V1 will be equal to I into R plus V2. When we write this equation, what we assume? We assume that the current is flowing from V1 to V2. And if the current comes negative, then we understand that we have taken a wrong direction. The current is actually flowing from V2 to V1. Now there is a problem with this synchronous machine or AC circuit. The problem is that in a let's look at this circuit. Here we are assuming that the current is flowing from V1 to V2. Now we know in a AC circuit current alternates, that sometime the current flows from source V1 to V2 and for some other time it flows from V2 to V1. That is, say for positive polarity, if it flows from V1 to V2, then for negative polarity it will flow from V2 to V1. Now for writing a KVL we have to give a direction. Unless this direction is given, we cannot write this KVL. Now the question is that how we will give this direction. It cannot be based on current because in AC circuits the current alternates. What this arrow shows actually is not the direction of current, but it's the direction of power flow. That is, when we give an arrow here like this, it means that the power is flowing from V1 to V2. Now after solving the circuit, if this result comes to be negative, it means that our assumption is wrong and the power is flowing not from V1 to V2 but from V2 to V1. Let's take an example. Let's say that in this problem V1 is equal to 1 at an angle 30 degree and V2 is equal to 1.2 at an angle of 30 degree. Now what does this 1 indicate? 1 indicates the magnitude of the voltage, which can very well be in per unit. So looking at these two voltages, we understand that V1 is higher in magnitude than V2. So let's draw the circuit once again. Okay. So based on our common sense, we understand that this voltage is more than this. So let's give the direction of power flow in this. That is, power is flowing from V2 to V1. Let's write a KVL for this. So what will be the KVL? KVL will be 1 at an angle 30 degree plus, let this be I at an angle theta, let this be X at an angle 90 degree plus I at an angle theta is equal to 1.2 at an angle of minus 30 degree. Now can you find the value of I? What will be the value of I? There will be X here. 1 at an angle of 30 degree plus I at an angle of theta into X at an angle of 90 degree is equal to 1.2 at an angle of minus 30 degree. Let X is equal to 1 at an angle of 90 degree. So we can write 1 at an angle of 30 degree plus I at an angle of theta into 1 at an angle of 90 degree is equal to 1.2 at an angle of minus 30 degree. So from that we can write I at an angle of theta is equal to 1.2 at an angle of minus 30 degree minus 1 at an angle of 30 degree divided by 1 at an angle of 90 degree. Now we will do the next part in the next class. Before we do that, what you do, you solve this and find the value of I and theta. Find I and theta. If I is negative, we will understand that power is flowing from this source to this source. If I is positive, we will understand that power will flow from this source to this source. So let's solve this problem, and we will you submit an assignment in Google Classroom stating that whether what is the value of I. What you will write is value of I sine of I and value of theta and sine of theta. In your assignment in Google Classroom, you will submit this, the value of I from this after solving this problem. What is the sine of I, that is whether it is positive or negative. Then value of theta, what is the value of theta. Then sine of theta, that is whether the value of theta is positive or negative. So once we have this value, we will again discuss what is meant from this solution. Thank you.